Hello engineers, welcome back. In this video, we're going to learn about the first traversal algorithm in graphs that is called the depth first traversal. Okay, I hope you're ready. Let's get started. So in this video, we'll look at how depth first traversal works. We'll code it in C++ and then we'll discuss the time complexity. Okay, let's get started. So let's use the same graph as before. So what is a traversal? What does the word traversal mean? It means that we need to go along the graph and somehow reach all the nodes. So traversal means visit each node once. We only need to visit each node once. Maybe we are doing some search, maybe we are trying to find something in the graph. For that, we are having to look at every vertex in the graph. So we need to use the concept of traversal. We need to somehow go through the graph and find out whatever we are looking for, right? So let's look at the other words. Depth first. So what does this mean? So this means that the algorithm will work in such a way that it will go deep into the graph first before looking at other path. It will go in one path, find its deepest vertex and come back up and then look in the other path, right? So if I look at it from this point of view, let's take a new color. So how will depth first search work? So we will pick a first node, starting node. We have to pick, it can be any node in the graph. So let's say I'm picking Sam as the first node. And from Sam, I need to go deep into the graph using one path. Let's say I'm going down this path. Okay. So once I hit Jerry, from Jerry, I will go deeper into Jerry's connections. I will go deeper into Jerry's connections. And then once I hit Harry, I will go deeper into Harry's connections. And if there are no more connections, then I will start returning from Harry. Harry's connections are done. Then I will look if Jerry has any other connections. If Jerry has other connections, I will go down that path. Otherwise, I will simply return back to Sam. Okay. This way, this side of the graph is now traversed or explored, right? Now I can go down the other path. I will go and check Tom's connections. If Tom has any connections, I will go deeper into Tom's connections. Yeah, once everything is explored in this path, I will come back to Sam. And then all the connections in this side of the graph are explored. Okay. If Sam had a new connection, let's say so if I start traversing this path from Sam, I will first reach Ben and then I will go to one of the paths of Ben. I will go to Matt first and explore this path. Once Matt is done, I will come back to Ben and then go down this path to Luke. I will come back to Ben and then I will go down this path to Jenny. I will come back to Ben and then I will come back to Sam, right? So this area will now be explored. So that is how depth first traversal works. We go down one path and then explore the entirety of that path and then come back and then start exploring a new path. So that is how depth first search works, right? So let's see how we can do this programmatically. So in the previous video, we learned about adjacency list, right? So this is how our graph look like. So I'm just taking the initial version for Sam. So 0 is Sam, 1 is Tom, 2 is Jerry. So Sam has two friends, Tom and Jerry. Tom has one friend, Sam. Jerry has two friends, Sam and Harry. Let's take Harry as well. Harry has one friend, which is Jerry, right? So this is our graph. So as you know, this is an adjacency list. This is an adjacency list, not a matrix, right? So how do we employ the depth first traversal algorithm on this? So like we discussed, first we will pick a starting node. It can be any node. We will pick Sam as an example. Okay. So from Sam, we will go down one path. Sam has two friends, right? We will go down one path. Let's say I'm going down the path of Tom, which is this path. Let me take a new color. So I will begin my traversal here. Okay. Once I have visited Tom, I don't need to visit Tom again, right? If in case I need to come back in this path somehow, I don't need to visit Tom again. So in order to avoid repeat visits, I will keep a vector like this, which will track if something is visited or not. So this will be of size of the number of vertices. So I have 4 vertices here. So I need to accommodate 4 elements in this vector. Okay. And what will be inside this vector? It will just carry true false. We can also do 0 1. We can do true false as well. Let's do true false. So initially the whole vector will be false, indicating that none of them are traversed. False means not visited. True means visited. Okay. So what will I do? From Sam's point of view, I go into Sam's vector. I find my first path, which is 1. So I change this to true. Okay. I change 1 to true. 1 indicates Tom here. So this is Sam. This is Tom. This is Jerry. And then this is Harry. Right. So now 1 is covered. I don't need to visit 1 again. Okay. So from 1's point of view, I will go to Tom's vector. I will go to Tom's vector and then start exploring Tom's vector. Okay. Since Tom is already a friend of Sam and Sam is a first node, we will also mark this as true. Sam is also a node that we have visited, since that is the starting node of our traversal. So both of them are true. Since Tom is having only one friend and Sam is already visited, we can come back from here. So we will come back from here and then we will go down a new path. We'll go down the path of 2. Now because we are visiting 2, we can mark this as true. And now we will go to 2's vector. This is Jerry's vector. From Jerry's point of view, we will first go down this path, which is 0. But 0 is already visited, so no need to do anything here. We will move forward to next one. We will go to 3. Is 3 visited? No. So we will mark it as visited. And then we will go to 3's vector, like this. From 3's point of view, we have 2. But 2 is already visited, so nothing to do. So we will simply return from here. So we will return back to Jerry, we will return back to Sam, and our entire graph is traversed. And each vertex is traversed only once. Okay, so that is how the algorithm works. Now let's code it and see. So we stopped here. We created an adjacency list graph. And for this graph, let's also add Harry. So added the Harry vector, and let's also add an edge between Jerry and Harry. So this is the edge between 2 and 3. So g dot add edge 2, 3. Okay, now our graph is ready. Let's create a new method for our depth first traversal. Void depth first traversal. I'm calling it DFT. So for this, let's create an start point. So let's call it start vertex, and I'm using 0 as my start vertex. You can use anything, right? And then we will create our helper vector, this vector, which will keep track of who is visited and who is not visited. So this will be a vector of boolean. We can also do vector of int with 0 and 1, but I am just using boolean here. So this will be the visited vector. Okay, what will be the size of this vector? This will be the size of the graph. And then everything will be initialized to false. So no vertex is visited as of now. Now we will create our helper method and we will pass in our start vertex and we will pass in our visited vector. Okay, now this helper method will do our recursion and then traverse through the entire graph. So let's create our helper method, which will be void DFT helper, and then we are taking in a start vertex. Let's just call it vertex here, and then we are also taking a vector of boolean. We will take it by address because we'll keep changing it through recursion. And then this is of the name visited. Okay, so what is the first step? First step is we have chosen the starting node, which is Sam, so we will mark Sam as visited. So visited of vertex will be true. Okay, so what is in this vertex? The number 0. We are passing in start vertex as 0 here, right? So visited of 0 will become true. So this is the visited array. Visited of 0 will become true. Okay, then what do we need to do? Then we go down the neighbors or edges of the current vertex, right? So that is under list of vertex, right? We have our adjacency list here. So we are going into this vector now. We are going into this vector. Okay, so let's use a loop to go through each member of that vector. So for int I equal to 0, I less than list of vertex dot size, whatever is the size of that vector, and then I plus plus. From here we can call our recursion, but before we call our recursion, we need to check whether the node or the vertex is already visited or not. So now we are here. We are checking if one is already visited or not. So let's extract that out. So let's call it int v equal to list of vertex of I. So this is where our v is. Now v is having the number 1, right? So we are checking if 1 is already visited or not. If visited of v, if this vertex is already visited, no need to do anything. But if it is not visited, then we will call our recursion. Then we will call our recursion with the new vertex, and then the visited vertex will be the same. Okay, this is visited. Right, what will this recursion do? It will go deep into one's vertex, which is Tom's vertex here, and explore this vector. If there is any new vertex which is found which is not in the visited list, it will go to that vector and continue to explore, and it will repeat the process until all the vertices in the graph are explored. Okay, so that is how this works. So how do we know whether we have explored? Let's just print it. Let's just do cout here, visited vertex and L, right? Just to see whether everything is visited or not. So now let's just call our method g dot dft. Okay, as you can see, we have visited 0, 1, 2, 3, and every node is visited only once because of our depth first traversal. So we can change the start vertex. Like we can also start with vertex 2. You can see here it started at 2 and went to 0 and then went to 1 and then went to 3. So it's like this. So it started at 2, went to 0 and then went to 1. It came back, and then it went to Harry. So from Jerry's point of view, first this path is explored and then this path is explored, right? So we can start our traversal at any node. So we can even take it as an input from this function call, or we can just do the first index. It is up to us, right? But the concept is we have used recursion to traverse through the graph one path at a time. We went deep into the graph and then we came back up and then we explored a new path, right? So that is how DFT works in graphs. So in this video, we have seen how depth first search works. We have also seen how it's working in code. Now let's discuss the time and space complexity, right? So what is the time complexity? So as you can see, we are using recursion. So we are making a number of recursive calls here depending on the number of vertices, we have to go to each vector at least once. So that will be O of V plus inside each vector, we are checking every element. So these are the number of edges, right? So these are the number of edges. So the overall time complexity becomes O of V plus E. And space complexity is we are using some additional space of the size O of V because we need this visited array, and the size of this visited array will be equal to the number of vertices. For each vertex, we need to keep track whether it is visited or not, true or false, right? So that's why the space complexity is O of V. Okay, and that's it. So I think that's it for this video, guys. We learned how depth first traversal works in graphs. So if you have any questions, definitely ask me. Don't forget to leave a like and comment if you found this helpful. Do subscribe to the channel and bookmark the playlist if you haven't done already, and share it with your friends. Thank you so much for watching. In the next video, we will study breadth first traversal. Okay, I'll see you in the next one. Cheers.